Hello everyone, welcome back to our channel. This is Dr.Nazma and in this video we are going to discuss NCERT Solutions of the chapter Some Basic Concepts of Chemistry. Let's get started with question number 1.21. The following data are obtained when dinitrogen and dioxygen react together to form different compounds. So the data is talking about mass of oxygen and nitrogen. In the first case it's 14 grams and 16 grams of each. But in the second case it is 14 grams of nitrogen, but it is 32 grams of oxygen. So if you compare the first and second data, the mass of nitrogen is same, 14 and 14. But then the mass of oxygen is varying. Keep this in mind while we take a look at the third point. Third point says 28 grams of nitrogen combining with 32 grams of oxygen. And the fourth point says that 28 grams of nitrogen is combining with 80 grams of oxygen. Even between third and fourth points, the same commonality is existing. The mass of nitrogen is same while the mass of oxygen that is combining is different. So now, if you have to answer this question, part A of this question, you got to say which law is this data reflecting, and you also got to tell the statement. You also have to state that particular law. So according to the masses and the relation between the mass of nitrogen and oxygen combining in each case, we can definitely say that law of multiple proportions is being followed. Law of multiple proportions is said to be followed when a fixed mass of one element is combining with a variable mass of second element to form different compounds. Like nitrogen 14 grams is combining once with 16 grams of oxygen, once with 32 grams of oxygen. So fixed mass of nitrogen but variable mass of oxygen. Similarly, 28 grams of nitrogen is combining with oxygen once with 32 grams of it, and second time it is 80 grams. So this condition is exhibited by law of multiple proportions, and the statement of law of multiple proportion is already written over here. The law states that if two elements combine to form more than one compound, then the masses of one element that combines with the fixed mass of another element are in the ratio of small whole numbers. So this is about part A of the question. Let's take a look at part B, fill in the blanks. So here you have the blanks, and literally it is nothing but unit conversions. You're converting one unit into other. In the first case, you're converting kilometers into millimeters, that into picometers. In the second case, milligrams into kilograms, that into nanograms. And in the third case, you're converting ml into liters, liters into dm3. Let's see how to convert it without fail. So the first one, converting kilometers into millimeters first. 1 kilometer is equal to 10 to the power 6 millimeters. And how do we make this conversion? 1 kilometer converted into meters has to be multiplied by 1000. 1 kilometer converted into meters, and this meters converted into centimeters by multiplying with 100. And this in turn can be converted into millimeters by multiplying with 10. Altogether, it is 3 plus 2 plus 1, 6 zeros, which is 10 to the power 6. 1 kilometer is 10 to the power 6 millimeters. And now, to convert this 1 kilometer into picometers, 1 kilometer is equal to 10 to the power 15 picometers. So to convert it into picometers, we have to first convert kilometers into meters. So multiply with 1000 and divide it by 10 power minus 12, because 1 meter is equal to 10 power minus 12 picometers. So you are converting 1 kilometers into millimeters, which is 10 to the power 6, and in turn into picometers, which is 10 to the power plus 15. In the second case, milligrams are to be converted into grams. Let's go back and check the question. Milligrams are first to be converted into kilograms, then into nanograms. So 1 milligram is equal to 10 to the power minus 6 kilograms. And similarly, 1 milligram is equal to 10 to the power plus 6 nanograms. Please note the difference, plus and minus. Okay. And now when I talk about converting ml into liters, we all already know, because liters and milliliters are one commonly used unit type in our real life. So 1 milliliter is equal to 10 to the power minus 3 liters, or you can also say 1 liter is equal to 1000 milliliters. So 1 milliliter is equal to 10 power minus 3 liters. And now I'm trying to convert this into dm3. And how do we do that? 1 milliliter is equal to 1 centimeter cube. 1 milliliter means it is 1 centimeter cube. And 1 centimeter cube being converted into dm cube now. 1 centimeter cube is equal to 1 centimeter cube into 1 dm. Observe this, divided by 10 into 10 into 10 centimeters, which is 10 to the power 3 over here. But if you get this into the numerator, it's going to be 10 to the power minus 3, which means 1 milliliter, which is equal to 1 centimeter cube, in turn is equal to 10 to the power minus 3 dm cube. So 1 milliliter is 10 power minus 3 liters, and it is equal to 10 power minus 3 dm cube. I hope you are understanding how to solve these questions, but in case of any doubts, you can always ask me through the comment section. Let's go on to question number 1.22. If the speed of light is given, calculate the distance covered by light in 2 nanoseconds. The speed of light which has been given over here is 3.0 into 10 power 8 meters per second. You got to calculate the distance covered by light with the speed in the time 2 nanoseconds. It's a pretty simple type of question, but then the point is you got to convert nanoseconds into seconds first, fine? So now, to convert nanoseconds into seconds, you got to multiply nanoseconds into 10 to the power minus 9. So 2 nanoseconds is equal to 2 into 10 power minus 9 seconds. And speed of light which is given is 3 into 10 power 8 meters per second. So now distance is being calculated. We already know the formula of distance, right? Distance is equal to speed into time. So since we are talking about light over here, speed of light into time taken by light. So speed is given 3 into 10 power 8, and the time taken for light is converted into seconds. You have to take the same value, 2 into 10 to the power minus 9. When you simplify this, the answer will be 6 into 10 power minus 1 meters. You can also write it as 0.6 meters. And now if you ask me why should we convert, or why should we write the answer only in terms of meters, you are taking the speed in terms of meters. That's why, fine. So now the next question, question number 1.23. This is a very important question, and also a question where you have to focus a little. So let's read the question first. The question is talking about a chemical reaction which looks like this. A plus B2 gives AB2. And now if this is the chemical reaction, you have to identify the limiting reagent, if any, from the following reaction mixtures. So this is the actual reaction, a balanced reaction. Now you have 5 cases given, 5 instances given. Now you have to observe each of these instances, and you have to tell which of the 2 reagent as per the quantities given over here is acting as a limiting reagent. Okay, let's take the first one to understand it better. So the first one says 300 atoms of A is reacting with 200 molecules of B. So first of all, you have to decode the balanced chemical equation. As per the balanced chemical equation, the ratio between A and B is 1:1. Did you notice it? It's 1 mole of A reacting with 1 mole of B to give you 1 mole of AB2. So whatever it is, let it be moles or let it be number of particles, let it be volume, whatever it is, the ratio between A and B should be 1:1. But now in the first case, they are saying that 300 and 200. Is this equal? Is it in 1:1 ratio? No, it is not equal. To react with 200 molecules of B, you just need 200 molecules of A. Equal proportion is needed. The other remaining 100 atoms of A are in excess. They are present in extra. So this is called as excess reagent. You call it as excess reagent because it is present in extra. Because this is present in extra, you don't have the other reagent to react. The other reagent got exhausted. You call the other reagent as limiting reagent. So to simplify this, during a chemical reaction, the reagent which gets consumed in the reaction first is called as limiting reagent. So here in 300 atoms of A and 200 molecules of B, the B molecules are lesser, so they get consumed first. That's why you call it as limiting reagent. So you have to identify the limiting reagent in these cases. So here the limiting reagent is B. Now if you have not understood it still, listen to me carefully in the second example. Second example is 2 moles of A and 3 moles of B. As per the balanced chemical equation, you should have 1:1 ratio of A to B. How much ever A you are taking, exactly same amount of B can react and vice versa. If you take one of them in extra quantity, it will not react, but it will remain back in the reaction vessel. So here, if you are taking 2 moles of A, you can only use 2 moles of B. B cannot react more than this, 2 and 2. But here in the question they have given you 3 moles. So 2 moles of B is reacted, but 1 mole of B is left behind in the container. So because it is left behind, you call it as excess reagent. So among A and B's quantity given, A is getting exhausted first. So you call A as limiting reagent. Now similarly, let's solve the third case also. 100 atoms of A and 100 molecules of B. So A is to B should be 1 is to 1, which means 100 atoms of A and 100 molecules of B, they are equal. So there is no limiting reagent over here. No limiting reagent because both of them are present in equal quantity, because of which they will be reacting with each other at par. Now the fourth one, 5 moles of A is reacting with 2.5 moles of B. So now 1 is to 1 is required. You have 5 moles of A but you have 2.5 moles of B. So if they have to react, 5 and 5 moles of each should be there. But right now you don't have 5 moles of B, you only have 2.4. So out of the 5 moles that you have, 2.5 will react with B. Then what about the remaining 2.5 moles? They will be left behind in the container. And what do we call those reagents which are left behind? We call them as excess reagents. Because A is acting as excess reagent, B will be limiting reagent because this is getting consumed in the reaction first. Next one, the fifth part. The fifth part is 2.5 moles of A and 5 moles of B. Applying the same logic, if you have 2.5 moles of A, you just need 2.5 moles of B. But you are having 5 moles of B. But you don't need it. So 2.5 moles of B will be left behind in the container. So you call B as excess reagent here and A will be called as limiting reagent. This is how we identify limiting reagents. In case you want to understand it again, you can also read through this solution, a detailed solution. This will help you. In fact, you don't understand it even after reading through it. If you still have some doubts, you can always reach me out through the comment section. Let's move on to the next question. Question number 1.24. The question says dinitrogen and dihydrogen react with each other to produce ammonia. And this is the chemical equation. N2 plus H2 gives 2NH3. So now with respect to this equation, we got to solve these three parts. The first one is calculate the mass of ammonia produced if 2 into 10 power 3 grams of dinitrogen reacts with 1 into 10 power 3 grams of dihydrogen. So first let us solve this question and then we'll come back to the remaining two parts. Let us consider the balanced chemical equation first, which is N2 plus 3H2 gives 2NH3. All of them are in gaseous physical state. So from the balanced chemical equation, we understand that 1 mole of nitrogen is reacting with 3 moles of hydrogen to give us 2 moles of ammonia, right? So 1:3 is the ratio of nitrogen and hydrogen during the reaction. If I convert this into mass now, 1 mole of nitrogen is 28 grams. So 28 grams of nitrogen is reacting with 3 moles of hydrogen. 1 mole of hydrogen is 2 grams. 3 moles is 3 into 2 grams, which is equal to 6 grams of hydrogen. So 28 grams of nitrogen requires 6 grams of hydrogen to react. Fine. And when this reaction is happening, how much of ammonia are we acquiring? We are getting 2 moles, but then what is it in terms of mass? 1 ammonia is 17 grams and 2 moles of ammonia is 2 into 17 grams, which is 34 grams. So this is the mass of nitrogen, hydrogen and ammonia as per the balanced chemical equation. If you take 28 grams of nitrogen, you will be getting so many grams of ammonia. 6 grams of hydrogen, you will be getting so many grams of ammonia. Fine. So now in the question, what are they talking about? They are talking about ammonia produced, mass of ammonia produced when 2 into 10 power 3. 2 into 10 power 3 grams of nitrogen reacting with 1 into 10 power 3 grams of hydrogen. Now first of all, observe the ratio between them. 2 into 10 power 3 and 1 into 10 power 3 is nothing but 2000 grams and 1000 grams, right? So now as per the balanced chemical equation, you got to have what? You got to have 1:3 ratio. And as per the balanced chemical equation, the moles should be 1:3 and the mass is 28 and 6, correct? And now, if 28 grams of nitrogen requires 6 grams of hydrogen, you are right now having 2000 grams of what? Nitrogen. And how many grams of hydrogen will this require? Cross multiply and check. 2000 into 6 divided by 28. This is the mass of nitrogen which is required, mass of hydrogen that is required to react with so and so given grams of nitrogen so that you can obtain the ammonia, right? But then the point over here is when you simplify this and check, it will not be 1000. It is something which is entirely different from 1000 and the simplified value around 428.5. So you just need 428 grams of hydrogen. But then how much of hydrogen do you have? You have 1000 grams of hydrogen. Do you need all of this for this reaction to happen? No, you don't need all of it. You just need 428.5 grams of hydrogen. So now when you take the difference, you have 1000 grams of hydrogen, but what do you need is only 428 grams of hydrogen. How much of hydrogen in excess do you have? You have 571.42 approximately grams of hydrogen. So this is excess reagent now. You don't need all of this. So this will be left behind in the container. And now your reaction will happen only between 2000 grams of nitrogen and 428.5 grams of hydrogen. I hope the point is clear with you. In case it is not clear, please listen to me once more carefully. So as per the balanced chemical equation, 28 grams of nitrogen requires 6 grams of hydrogen. And now in the question they are saying that you have 2000 and 1000 gram of hydrogen. But now I'm just calculating 2000 grams of nitrogen require how much of hydrogen for the reaction to happen. And the calculation says that you just need 428.5 and so, which is rounded up here to 6, 428.6 grams of hydrogen. So you have 1000, but you require only this much. So how much of nitrogen do you have which is not necessary? You are having 1000, out of which 428.6 is to be used, and the rest of the quantity of hydrogen is going to be excess. So now we have to conduct the reaction between this 428.6 grams of hydrogen and 2000 grams of nitrogen. I hope the point is clear. Let's come back to the question and check the question once more. In the question they are asking us calculate the mass of ammonia produced when this reaction happens, right? So now to be able to understand it better, let's clear the page and let's write it. So now I'm having 2000 grams of nitrogen reacting with how many grams of hydrogen? Here 428.6. It is reacting with 428.6 grams of hydrogen. But then that's not what is important. It's important for us to calculate the mass of ammonia produced. When 28 grams of nitrogen reacted as per the balanced chemical equation, I had 2 into 17, which is 34 grams of ammonia produced. So here 28 grams of nitrogen as per balanced chemical equation is giving me 34 grams of what? 34 grams of nitrogen. So now as per the given data, if I react 2000 grams of nitrogen, how much of ammonia will be produced? Cross multiply 2000 into 34 divided by 28. And when you simplify, your simplification says that the mass of ammonia that's going to be produced is 2428.57 grams. So this is the mass of ammonia. Now we have solved the first part of the question. But then while solving the first part of the question, we also have realized that hydrogen is present in excess. Correct? Hydrogen is an excess reagent. Keep that in mind. Now let's read the second part of the question. Will any of these two reactants remain unreacted? Now you try asking yourselves this question and identify the answer. Out of the nitrogen 2000 grams and hydrogen 1000 grams, is there something which is left behind in the container unreacted? Answer should be yes. Hydrogen is left behind in the container unreacted because it's in excess. It's present in too much quantity. That's why. Now let's read the third question. If S is your answer for the second part of the question, which one and what would be? Hydrogen is that one, and what is the mass of hydrogen left? Do you remember? It has to be 1000 minus 428.6. 1000 minus 428.6 is 571.4 grams. This is the mass of hydrogen which is left behind in the container. I hope you're clear about how to solve this question, but then the questions based on limiting reagents are often confusing, so you have to be extra careful and you have to double check your answer when you're writing it in exam. In case you want to ask me any doubts about this question or any other questions of chemistry, please let me know in the comment section. Let's move on to question number 1.25. How are 0.50 moles of sodium carbonate and 0.50 molar sodium carbonate different. They are talking about 0.50 moles and 0.50 molar. We know the difference between moles and molar already. You remember the difference? So N signifies number of moles, and number of moles is weight by gram molecular weight of the substance. Similarly, molarity is the ratio between number of moles and volume, right? Molarity talks about concentration, but number of moles talks about amount of mass. They talk about amount of mass. But anyways, let's understand the difference mathematically. Molar mass of sodium carbonate can be calculated as 106 because you sum the mass of sodium atoms, carbons and oxygens present in this molecule. So now 1 mole of sodium carbonate means 106 grams of sodium carbonate, correct? So now 0.5 moles means how much? Why 0.5? In the question they are talking about 0.5 moles, right? That's why. So 1 mole is 106 grams. 0.5 moles will be how much? Cross multiply 0.5 into 106 divided by 1, which in turn will be equal to 53 grams of sodium carbonate. When I say 0.5 moles of sodium carbonate, I'm talking about 53 grams of sodium carbonate. Fine. This is the first part. And the second part, they are talking about what? They are talking about molarity. 0.5 is molarity. Fine. And we already know that molarity is spoken per 1 liter. Correct? So if I say 0.5 is molarity of a solution, I mean to say the volume of the solution is 1 liter. Fine. So you know molarity and volume, and I told you that molarity is equal to N by V. Can we substitute molarity and volume to identify number of moles? Absolutely we can. Correct? So N is equal to molarity, which is 0.5 into 1. 1 is volume, 1 liter. So N is equal to 0.5 moles again. So if 0.5 moles it is, what does it mean? If it is 0.5 moles, when I look at the mass of the sodium carbonate, it is going to be 53 grams itself. So 0.5 moles of sodium carbonate is 53 grams. Similarly, 0.5 molar sodium carbonate solution is also 53 grams. But the difference is, in the second case, when you're talking about molarity, you have dissolved 53 grams of sodium carbonate in 1 liter of water. The physical state is different. Are we clear? Fine, perfect then. So these are the questions from NCERT exercise of the chapter number 1. The rest of the questions will be solved in the next video. Until then, guys and girls, bye-bye.